Hey, what's up guys, back again with another video in the Spigot series. This time I'm going to show you how to make your very own player vault plugin. Alright, so last episode, the last two episodes, we learned how to make, or how to use persistent data containers to store primitives and strings within players, items, and there's also a way you can do it with blocks. And then we also learned last episode how we can serialize and encode and decode and deserialize items and locations and stuff like that with magic. And so what we're going to do this episode is show you how you can use, or how to make a player vault plugin so that the player can basically have a private inventory, sort of like an enderchest, and then they can store items in that inventory, and then it's going to be saved as a encoded string in their persistent data container, and it's going to be really magical. Okay, so let's try doing that. So first things first, let's go ahead and make a simple command here. So we'll make a package first. We'll call this commands, and I may go far with this plugin, maybe not. We'll see how I'm feeling about it, but yeah. So let's see what we got. Let's make a simple command called open command, and this is going to be a simple command that allows them to open their player vault inventory, obviously. So command executor, all that wild jazz. And okay, so let's also make another package called listeners. And the way we're going to be designing this is, as the player joins, we're going to be assigning them a value called like vault or something to their persistent data container, and that's going to store the string for their player vault basically. So let's do this. Implements a listener. There we go. And the first thing we're going to do is event handler and public void on player join. So that'll be the player join event e. And I think we did this 2 episodes ago. I showed you how to do this exact thing, so you should know how to do it, I guess. So player p is equal to e.getPlayer, and so now let's get the player's persistent data container. So p.get persistent data container, and so now we can check to see if that persistent data container already has the value that we want to check for. So opposite data.has new namespace key. And in that, we need to provide an instance of our plugin here. So let's go ahead and go back to our main here and make that a getter for that. So private static vault plugin. And then as the plugin starts up, we'll do, oh, we need to give this a name, don't we? So plugin is equal to this. And then now we'll just create a getter for that. So code generate getter, boom. So now we can get an instance of our plugin within other classes. So we could do get, or no, vault plugin, since it's a static method, vault plugin.getPlugin, and then now we need a identifier for our namespace key, and we'll just call this we'll call this vault. That makes sense. It's a fitting name, I guess. And so what else do we need? We need a persistent data type. That's going to be a string in this case, because again, we're using the base64 encoding, which is a string. And so if they do not have that, that means that we want to set it for them. So data.set, and we'll just copy all of this here, so we don't have to type it again. Then we need the third parameter, which is going to be the thing that we want to set it to, the value. And we'll just provide an empty string right there. So there we go. We have the simple listener. So whenever the player joins, we're going to see if they have the vault key in their persistent data container. If they do not have it, then we're going to give them that value or the key, and then assign it a default empty string as a placeholder, basically. And so let's make a third package here called utils, and this is just going to be a bunch of static methods that are going to help us work with the player vault, basically. Okay, so utils, we'll call this vault utils. So the first thing we want to do is provide a way for serializing all of the items in their inventory. So the way we're going to do this is I'm going to show the player an inventory, an empty inventory, if this is their first time joining. And they're going to put all of the items that they want to store in their vault into that inventory, which is going to represent their vault, obviously. And then when they click, or when they close the inventory, we're going to take all of the items in that inventory and then serialize it. So we're going to take all of those item stacks, serialize them together, and then encode them together. And then we're going to take that encoded string and then store it in their persistent data container. And then whenever we want to get the data or like get all the items and then put it back into an inventory. So like the next time they open the inventory, we want to do the opposite, right? We want to take the string of all of the items that haven't been encoded, decode it, and then deserialize it back into a list of item stacks, and then take all those item stacks and then put them back into the inventory. And yeah, so that's how that will work in essence. So now let's go ahead and make a simple method that is capable of taking a list of item stacks, then serializes all of them together, and then encodes them all together into a string and does exactly what we explained a second ago. And yeah, so let's do public static void, we'll call this store items, and let's provide or have them provide a list of item stacks, and we'll call this items obviously, and then player p, because we need the player to be able to store the string in their persistent data container, right? So make sure player is imported. There we go. Alright, so the first thing we want to do is get the persistent data container like we always kind of have done. So data is equal to p.get persistent data container. So this method here will be called whenever the player closes their inventory, and then all of the items of that inventory will be sent to this function here, or method here, and encoded and all that stuff. So we want to see if the items that were sent to this method here, if it's equal to 0, if the size is equal to 0, that means that the inventory that they just closed was empty, so there's nothing really to do, there's nothing to encode, right? So let's just check that first. So items.size is equal to 0, meaning that no items were provided, meaning that the inventory that they just closed, their vault, is now empty currently, basically. So now we can do data.set new namespace key, and we can just go back to here and just copy this. So just set it to an empty string because their player vault is now empty, so there's nothing really to set. So we'll just put an empty string, okay? So otherwise, if the items that they provided is not equal to 0, the list is not equal to 0, that means that there is at least one item in their inventory when they closed their player vault, okay? So now we want to take that and encode it, or serialize it and then encode it. So first things first, we need our byte array output stream. So byte array output stream, we'll call this IO is equal to new byte array output stream. And then we need our bucket object output stream, which is going to take a bunch of objects and then serialize them. That's going to be equal to new bucket object output stream, and then that's going to be connected to our IO, the above stream. And of course we want to try and catch this in case an exception happens. So IO exception. Alright, there we go. And so now what we can do is feed it. So now we can feed the stream objects to then serialize them. But before we feed it the item stacks, we want to feed it the amount of item stacks so that when we do the reverse, when we deserialize it, we know how many times to loop through it. And we'll see this in a second, so just take my word for it first. So what we need to do first is do os.write integer and then provide the size of the list. So items.size. So that will tell us how many times we want to loop through our list here. And then in the reverse, we want to use that same size to tell it how many times we want to, or how many objects we want to grab from the stream, the byte array input stream, and the bucket object input stream, okay? And we'll see that in a second. But now that we have that, we can then write our item stacks to the stream. So I is equal to 0, I is less than items.size, and then I++. So for however many item stacks are provided, we want to write each of those into the object stream. So write object, and then we could do items.get I, and so that's just going to write each one of them into there. So you can imagine it something like this. So the first is going to be the size. So let's say we have a list. Let's say we have been provided a list of 3 items. So that means that the first thing in our stream is going to be 3, and then the next thing is going to be item 1, then item 2, and then item 3. And that's just going to be converted to byte arrays and binary whatever when it's serialized. But then when we want to decode it and then deserialize it, we're going to do the exact reverse basically. So first we're going to grab the first integer of our byte array, which is going to be 3 in this case, and we're going to store that in a variable. and then we want to use that amount to know how many times to loop, so we know how many objects we need to grab from the stream, because there's no other way to know, right? If it's just a random byte array, being fed through an input stream, then we don't know how many times or how many objects are in that stream. It can be any amount of objects. So if the first thing we store is the amount of objects that are in the stream, we can then use that amount to know how many times we need to grab an object from the stream, basically, okay? So yeah, hopefully that makes sense. And again, like I said 20 times now, we'll see that in a second. So now that we have added all of these objects into the bucket object output stream and serialized them, we can then put that into a byte array like we did last time. So raw data is what we'll call it. And we'll do io.toByte array. So now we have taken all of the items and the amount of items and put that into a stream and then serialized it and then put that into a byte array. And so now we can use that byte array and then put it into a string called encoded data. So we'll do base64.getEncoder.encode to string raw data. And so that's just going to encode it to the base64 format. And actually one more thing we need to do before that is flush the stream. So os.flush, because you can't forget to do that. Just make sure everything's pushed from the buffer to the stream or whatever. And yeah, so that should do the job. And so now what we need to do is put that encoded string into our player persistent data container for storage and retrieval for later at a later date. Okay, so now let's just copy this up here. So instead of providing an empty string, we'll just provide the encoded data string, which is our encoded inventory or items in this case, okay? And so once we're done, we could do os.close, which is actually something I forgot to show you last episode, but that's okay. You don't really have to close it if you don't, it's important to close it, but you don't really need to. It's not essential, but you should close your streams when you're done using them. So yeah, that's a pretty simple process. What we're doing is just taking all of the items that were provided in the list as a parameter, then writing that size into the stream, and then after that we're writing each item stack into the stream, which is going to serialize everything, put that into a byte array, then encode the byte array into base64, and then store that new string base64 encoded thingy-majiggy into our player's persistent data container, which we're then going to grab for the next time they open their player vault. So we're going to do the exact opposite, okay? So let's go ahead and make a function or a method. Sorry, I just made a C++ video, so I keep saying function. But let's go ahead and make a method here for doing the exact opposite, which is going to be taking the string from the player's persistent data container and then deserializing and de-encoding it to get a list of all the item stacks that have been stored for their player vaults, okay? So public static array list of item stacks, and then we'll call this get items. I guess that makes sense. And we just want to provide a player so we know the persistent data container to use. Alright, so the first thing we want to do is again grab our persistent data container for the player, and then let's make an array list of item stacks to store all of the items that we're about to retrieve from the player's persistent data container. I'll call this items. Alright, cool. Okay, so the first thing we want to do is grab the string from their persistent data container. So we'll call this string encoded items is equal to data.get, and then we'll just copy this new namespace key and then persistent data type string. So that's going to grab the string that's stored in that location, and we're confident that this is going to work and not return null or anything like that, because in our listener here we're making sure that each player who joins has at least a default empty string initially. So yeah, so now it's going to put either an empty string in this string here, or it's going to put an encoded base64 string. So let's check to see with an if statement if it's an empty string first before we move on. So if encoded items dot is empty, we'll just actually just do the opposite. So if encoded items is empty, so if encoded items is not empty, then we can safely assume that we can then begin the deserialization process and de-encoding process. So we need to decode first, so byte array, and we'll call this raw data, and we'll do base64.getDecoder.getDecode, and then just provide the string that you want to decode into a byte array. So just encoded items. So that should do that for us, and then we want to then open up this here, just handle these exceptions again, IO exception, S out, EX. And so inside of here, just want to do what we did last episode. So byte array bytes array input stream. We'll call this in is equal to, or we can call this in is equal to byte array input stream, and then byte or bucket object input stream. We'll just change this one to IO and just call this one in. Doesn't really matter. And we'll say new bucket object input stream. And now inside of here, we just want to provide the data that we're streaming. So raw data is going to be placed into our byte array input stream, which then we can use our bucket object input stream to then take the data from the byte array input stream and then form into objects. And we also want to provide IO inside of that, so we can do that too. So before we begin grabbing objects from the stream, the first thing we need to grab is the size. Remember, that's the first thing we put into our stream. Our byte array is the size of the list of items. So we want to grab that size so we know how many objects to grab from the stream, okay? So we'll do integer items count is equal to in.get integer, in.read integer. So that's just going to read the first integer of the stream and put that into a variable. And so now we can loop through that amount. So let's just do that. I is less than items count, I++, and then items.add. So we want to just add to this array list that we have here. So we just want to grab the item. So in.read object. So that's going to grab the object from the stream, or the next object from the stream. And then, of course, we need to cast it. Well, first we need to do the class not found exception, and then we need to cast it to an item stack because it's just an object by default. If you control Q here, it's just an object that's being returned. So you can cast that object to an item stack because of course an object is an item stack is an object, right? And then finally, we want to close the stream once we're done using it. Okay. So hopefully that all makes sense. But just to recap one more time, we're grabbing our encoded string, then checking to see if it's empty or not. If it's not empty, then we can continue and put that, we can decode that into a byte array. And then we can put that byte array into a byte array input stream. And then we could use a bucket object input stream on top of that to read data from the byte array input stream to deserialize it. And so the first thing we want to grab is the size, so how many items that we're about to be grabbing. And then we're going to grab that size, put that into a variable called items count. And then we're going to use that amount to know how many times we want to loop. And then we're going to, for each iteration of the loop, we want to just read one single item stack and then put that into our array list here. And then once we're done with all of that, we then want to return our array list to whatever place it's being called from, okay? And hopefully that all makes sense, but that's pretty much it for that. That's the hard part for this episode. So now we can go back to our open command and do the pretty easy part, which is just using those two methods. So we want this command to be /vault open, and then that's going to grab their player vault and display the inventory of their player vault to them so they can add new items, take items out, and stuff like that, okay? So we want to have an array list here of all of the items that they're, actually first we want to check to see if they're adding the open argument. So if sender is instance of player, then we'll do player p is equal to player sender. And so if the command or args.length is greater than 0, then we want to check to see if the first argument is equal to open, right? Because we want to the player to be able to do /vault open. So args0 dot equals ignore case open. So if it is open, then we can assume that they want to open their vault, of course. So first things first, we want to get an array list of all of the items that represents their current vault, that are in their current vault. So item stack vault items. And so we want to do vault utils dot get items and then pass in the player. So what that's going to do is get all of the items in the player's vault currently, put that into an array list, and so now we can loop through that array list and then add it to an inventory. So let's create an inventory for that. So inventory vault is equal to bucket dot create inventory, and the player owner, or the inventory holder, is just going to be the player. and our P in this case. And so the size of the inventory will just be 54, max size. And then finally the title will be your personal vault. Okay, and we can change that later if we want to. So import inventory. And so now we can just loop through this array list of all the items that our inventory has, and then put them into this inventory basically. So we'll do vault items dot stream, and then for each, and item stack vault dot add item, and then just pass an item stack. So all of this is going to do is just a basic stream. It's just going to loop through all of the item stacks in our array list here, and for each iteration of that loop, it's just going to add that item stack to our inventory using the add item method of the inventory class. Okay, so that should do that for us. And then finally, don't forget, we need to do player.openInventory or p.openInventory, and that'll open it for them. So there we go. So one more thing we cannot forget is whenever the player closes the inventory, we want to get all of the items in the inventory and then save it to their persistent data container. Okay, so we're going to make a second listener for this, public void on inventory close. So we'll just get the player that this is affecting. So e.getPlayer, and then if e.getView, and we're just going to check the title of the inventory, just a simple title match. So e.getView get title equals ignore case your personal vault. So if the inventory that they just closed is titled your personal vault, that means that we know that they just closed their personal player vault, obviously. So now we want to grab each item in that vault and then send it to our store items method here, which is going to store it in their persistent data container. So normally you might think you could just do vault utils dot store items and then just do p.getInventory dot get contents, which is going to get all of the items in their inventory, and then just pass in p, and that would send each item in their inventory to the method and store it and all that stuff. But the problem with this is that if you do Control Q here, it says an array of item stacks from the inventory, individual items may be null. So if a slot in the inventory is empty, it's just going to give you null as in the item stack array that it's returning here. So that's problematic. So what we need to do is loop through the item stack array that is provided by this getContents method, and make sure that we're skipping over the null values, because like I just mentioned, everything that's empty, every slot that's empty in the inventory that we're grabbing the contents from is going to be null, and we don't want any null exceptions, right? And we can't serialize a null value. That doesn't make sense, right? So we only want to grab the item stacks, not the null slots, basically. So hopefully that makes sense. So we're just going to grab this and we're just going to stream it. So stream, there we go. So arrays.stream, and so we're going to filter it. Hopefully you're familiar with the stream API. It's pretty simple. So we just want to filter it. So item stack, and so for each item stack in the array, we're going to check to see if it's null, and if it is null, then we want to skip over it. So item stack is equal to null. If it is null, return false. So it's going to be filtered out. Otherwise, return true. So it's going to go through the filter. And then dot for each, we're going to put this into an array list because our method here is asking for an array list as the first parameter. So array list item stack. We'll call this pruned items. Import array lists, and then we'll call this pruned items, because we have filtered it and whatever. I guess that makes sense. So new array list, and for each item stack that passes through the filter of null, we want to add that item stack to our array list here. So item stack pruned items dot add item stack. So hopefully that makes sense, but it's just going to filter through the entire contents of the player's inventory that they just closed, which is their vault inventory, and then we're going to skip over all the empty slots, which is going to return null. We don't want any null exceptions, so we're going to skip over those, filter through them, and then put all of the item stacks that are not null into an array list, and then we're going to take that array list and then feed it to the store items method, which is then going to do its magic by serializing it into a byte array and then encoding it into a string and then saving that string to the player persistent data container, and then we can grab that later next time they open the inventory. Okay, so that's actually it for that. This should be all we need. So now let's go ahead and go back to our main here and register everything. So git command vault.setExecutor new open command, and then we want to register the listener. So git server.get plugin manager.register events new listeners, and then this. There we go. And then finally, we want to use our plugin.yml, register the command here. Okay, cool. So that should do that for us. Let's go ahead and compile this now to see if it works in our server. Alright, so I'm on the server now, so let's try doing /vault open. And now we get my personal vault. Awesome. So that's already working. So now let's go ahead and put some items inside of here. See what we can do. Just put everything inside of here. Now we're going to close it. Escape. So that's going to close it. So what that should have done is serialized all the items and then put that into my persistent data container. So now we're going to open the inventory, which is going to do the exact opposite. Grab the thing from my persistent data container and then deserialize it, decode it, and all that. Okay. So we'll do /vault open, and it's empty. So okay, something didn't work. Okay, so I found the mistake here. In this case right here, when I close the inventory, I'm doing p.getInventory.getContents. I should do e.getInventory. So we're getting the inventory that was closed, not the inventory of the player. So that's just a little bit of a mistake there, but that should fix the issue for us. So let's go ahead and recompile this and throw this back into the server to see if it works now. Okay, so let's do /vault open. Then we'll put some items inside of it. All that wild jazz. And then we'll close it and we'll open it back up, and there we go. So we get all of our items here. As you can see, it places them into like a full stack. Even if I spread them out, it puts them into a full stack, just because that's what it does automatically if you're just putting items into an inventory. But if you want to have it in the same spot, then you could add that in there if you want to. Just keep track of that whenever you serialize it and stuff like that. Maybe I'll do that in the future if I work on this plugin some more. But that's basically exactly what we expected. So that's a very, very simple player vault plugin, so that the player can now put items into a vault, close it, and then when they open it back up, it's still there. So if I was to restart the server right now, all of the items would still be there because it's stored persistently in our persistent data container. And you can play around with this some more, maybe develop the plugin more, add some buttons maybe at the bottom to close the inventory, and some more advanced stuff like that. But that's all I'm going to show you for now. So in the future episodes, like I said, I might work on it some more, so stay tuned for that, and let me know if you want to see this plugin actually developed some more, and maybe I'll even release it if it gets good enough. So just let me know if you want to see that, and you can also leave suggestions for future videos if you want to. Just let me know what you want to see and I'll make videos on it. If you have any questions about what I showed you this episode, feel free to leave a question in the comment section below or join our Discord server. We have a big Discord server with over 1,300 members last time I checked, so if you need any help at all with your programs, you can hop into one of these help channels and get some help. You can also just hang out and get some new friends if you want to, so just make sure you click the invitation in the description below. Don't forget, in the description below, I'll also leave a link to the code for this episode, so you can come back to it at any time and use it as a reference. I'll leave good detailed comments around the code so you can have a good explanation in text form too, in case you don't want to watch my awesome videos again. One final thing I want to tell you about: if you want to support this channel, you can click the join button below this video, and you can join this channel as a member for as low as 99 cents a month. If you join, you can get cool perks like a special Discord rank on my server, early access to these videos, and you get shouted out like you see on the screen right now. If that sounds good to you, feel free to join for, like I said, as low as 99 cents a month. Alright, that's it. So thanks for watching. If you like this video, leave a like. If you want to see more, subscribe. And peace.